All right, solving for a specific variable. Section 8, let's roll. Dimensional analysis. No, we're not talking about the third dimension, the fourth dimension, the fifth dimension, or 4G or 5G or whatever our phones are working on. Nope, this is the process of carrying units throughout a computation, otherwise known as a equation. That's what this looks like. It's probably the easiest way to go through this. So solve this equation for a specific variable. So in this case, there are two variables in here. And this one says we need to solve for b. So we need to move everything away from b. So we're going to start that out by writing the original equation. We're going to we can take this whole thing at one time. We don't have to divide it over. We can take the entire term with the plus minus here. So that whole term can go over. So subtract 12c from both sides. Then we can simplify that out. Now b's over here with a 5 attached to it. Well, we know how to get b by itself. All we have to do is divide by 5. So we divide the entire second side on the right here. It takes the whole thing. It's not just one or just the one with c. The whole thing has to go over because the whole thing's here. So we have to divide under the whole entire part, which would put that all together. Now we can simplify that a little bit. Usually we want c to be first, but this will probably be just fine. So the value of b is, ta-da, moving along. So pause this, give it a shot. All right, so we start by rewriting the equation. 2x minus 17y equals 13. We need to get y by itself. So I can take this entire piece here. Opposite of positive is negative, minus 2x. So that's going to give me negative 17y equals 13 minus 2x. Since these are different type, these are not like terms, they just stack up next to each other. Should have said that on the last one as well. So now I can divide by negative 17. I can divide by negative 17, which will leave y by itself. And this will go underneath the entire thing here. So 13 minus 2x over negative 17. That's what we're going to look for. Can that reduce? Bam. I guess they flipped those, the 2x and the 13. That's okay. Moving along. All right, solve the equation for the specific variable. So we have lots of variables here. X, y, and z, and an extra x over there. So slightly more complicated, not much though. So first we rewrite the original equation. I would probably start by subtracting 4 to get it to the other side. Oh, never mind. They're going to make x, y positive. That makes sense because you want to get both the x's on the same side. So now all the x's are on the left-hand side, and they're both positive. That'll make life a little bit easier. So then we're going to add 2z to get this 2z to the other side. We'll simplify that out. From here, we are going to pull x out of both using the reverse of the distributive property. Since x is in both, I can pull x out of both to get it by itself. From there, we divide by 7 plus y on both sides, and that should leave me with x by itself. So my answer is going to be this, equals x. So the value of x is whatever all that is. Since the division is by 0, it is undefined. So we have to say that y cannot equal negative 7 or y can't equal 0. Basically, whatever makes the denominator here 0 will not work. Pause this, give it a shot. All right, so we need to get a by itself here. So let's see. I think I'm going to take this that way. It'll still end up being negative. There's going to be a negative no matter what I do. So minus 2ab minus 2ab So I'm going to stick it in between here. So it goes 12a minus 2ab plus 3c. So I did that one, that one, that one, equals 6. I can subtract over the 3c. Again, they're not like terms, so they'll go next to each other. From here, I can take this a out of both sides. Or both sides, both terms, I can distribute that out. And then divide by 12 minus 2b. I should have technically brought that down. And then divide by 12 minus 2b. And my answer is going to be a, because those will cancel, equals 6 minus 3c over 12 minus 2b. Sweet, I even had it in the right order. All right, a car's fuel economy, E, miles per gallon, is given by the formula E equals miles over gallon, economy equal, since the world's all worried about miles per gallon right now, where M is the number of miles driven and G is the number of gallons of fuel used. Solve the formula for M. So they gave me the formula, yay. So now I just need to get M by itself. Well, the only thing I can do is multiply both sides by G. Since it's divided by G, I multiply by G. And that gives me EG equals M. So economy is gallons times gallons equals miles. So if Claudia's car has an average fuel consumption of 30 gallons per mile, or miles per gallon, and she uses 9.5 gallons, how far does she drive? Well, using the formula we just found, her average fuel consumption is 30 miles per gallon. So that would be her economy, 30 miles per gallon, times that by 9.5 gallons. And that gives me she drove 285 miles. And go. Okay, so we would take our original equation, E equals M over G. I need to solve for G, so I'm going to multiply by G first. Sorry, terrible G. So it gets me exponents per gallon equals M, and now I'm going to divide by E. I'll just speed this up and just go E over E. So G equals M over E. There we go. If Claudia drove, oh, sorry, you should try first. All right, if Claudia drove 1,477 miles in her pickup with an average consumption of 19 miles per gallon, how many gallons of fuel does she use? So I'd take we want to know gallons equals, let's see, it was miles over economy. So if she goes 1,477 miles at 19 per gallon, we can, let's write that into my calculator here, 17.7374. 77.74. That's rounding. Moving on. All right, the volume of a cylinder. That's a terrible cylinder. Anyways, the volume of a cylinder is volume equals pi r squared times the height, where r is the radius of the cylinder and h is the height. Solve the formula for h. So we're going to write the formula first for the volume of a cylinder and probably just divide out the other two pieces. Divide by pi r squared on both sides. H equals volume divided by pi r squared. All right, so the height of the cylinder of a cylindrical swimming pool that has a radius of 12 feet has a volume of 181 cubic feet. So we take our formula that we just created. We punch in the numbers. We square the base down there. Oh, sorry, just put it into your calculator. Ta-da! Height of a cylindrical swimming pool is about 14 feet. All right, pause this one, give it a shot. All right, so v equals pi r squared h. Well, first we have to take pi and h over. So we're going to divide by pi h. Divide by pi h. Gives me v over pi h equals r squared. The inverse of squared is square root. So square root both sides. Give me the square root of v over pi h equals r. Look at that. Moving along. What is the radius of a cylindrical cylinder pool that has a volume of 210 feet and a height of 6 feet? Oh boy, so we take that one that we just did, equals volume over pi times height equals r. Oh boy. So we put in a height of 6, a volume of 210, and times that by pi. All right, so be really careful putting this one into your calculator. I came out to approximately 10.33 feet. So the closest answer I had to that is 10 foot, but it doesn't come out to straight up. You know, when you multiply pi times 6, or 2010 divided by pi times 6, it comes out to like 106 something. So just be careful on that one. It doesn't come out right at 100 like it probably should, or right at 1,000.